You're live, right? Yeah. Okay. Hi, welcome back, everyone. I believe you have had your coffee and tea after the break. So, in this part of the session, we will start with, as sent out by email, an elevator pitch by the projects, and we will invite you one by one to the stage. The way this will work is we call out the project name, and you can raise your hand. If you can see a reactions button at the bottom of your AirMeet screen. From there, you should be able to see the button of raise a hand. So when you raise the hand, we can invite you on the stage to make your pitch. um, Other, if you don't find the raise hand button, then you can also put your name in the chat when I call out the name of the project that you are representing, so that you will be invited to the stage. um, Please make sure that you finish your pitch within 5 minutes, so that we can finish this session on time. Okay, then let's begin. I'll call the first experiment on the stage. That's Turi Lab. Please raise your hand, the speaker from Turi Lab.
Or put the name on the chat about the one who will be the presenter.
Mm,
Sorry there. I had some technical issues.
hey, man.
Hi there, Rajiv. Sorry, but I couldn't connect to the internet, so yeah. I suppose I have to present my pitch, right?
Yeah, you
Yep.
can start.
So I've just got one screen today, so yeah. I mean, let me see if share screen. Okay. Can you see my screen now?
Yes.
Okay. So basically, our experiment is called True Lab. We are a consortia of 7 entities. One of them is the regional digital innovation hub here in the Canary Islands. As you know, the Canary Islands belong to Spain, and we are like a very important tourism destination place, right? So, sorry, I don't know if okay, so our experiment is regarding the exchange of data in a sustainable tourism environment. So, as you must know, is that tourism is one of the most important industries in the globe, and mainly in the Canary Islands. So that's our focus to it. But we have put an additional component, that's the Sustainable Development Goals by the UN, because obviously what we are going to do in the world from the start is to be more sustainable. Right now, things are like a bit crazy, and we want to give an, an extra, uh, you know. Focus to the sustainability of this experiment. So what we want to do is to reduce, to promote the reduction of carbon footprint, and those different silos that traditionally there are in the tourism industry. We want to um, change that aspect into something more collaborative, so other opportunities can arise from this, so mainly what we are going to do is to share data between different tourism entities, so they can create new business models, oriented or towards the data sharing. So yeah, these are different aspects that are going to be enhanced thanks to our experiment. And I don't want to. I just yeah. I want to focus mainly on the experiment, which is to have a data flow for a more secure, sustainable, and trusting real-time sharing of data, which is perfectly aligned with the I4 Trust initiative. And we want to, as I said before, promote a more eco-aware tourism model and to create new business opportunity for local SMEs. This is the consortium members. There is a City Hub, which will be the digital innovation hub that holds the experiment. MNX Online, which I represent, is the main coordinator of the experiment. And here come the other entities such as Clean Carbon, which will have this how do you say sustainability rating in which we will base our current use case. Okay, so I'll explain that later. And Norai is a company that offers um, that has a lot of data regarding the actors in a tourism market, because they have been like for many years providing technology regarding how do you say um, regarding management of hotels and accommodation. And then there are the service consumers that will be Buenavilla, Van Campers, and Grafos, which are Buenavilla is an accommodation company. Van Campers is an alternative accommodation company with the camper thing, and Grafos is a IoT company here based in the Canary Islands. All of them are in the Canary Islands. Grafos is another company that is in La Palma, and they have these IoT devices that check for users how do you say state of mind. Okay, so this is the technical aspect of the architecture. So here it's like how we share the data and all this, but mainly this is the use case that we have provided for this experiment, in which, as I said before, we will use this Carbo score, that is a sustainability score for both companies and tourists, that will be used to enhance the tourist profile from Norai. Um, and then afterwards, that tourist profile can be used by the end consumers, such as Van Campers, Buenavilla, and Grafos, to see how people, how their their um, um, their customers are, so they can give them a more how do you say a more uh, sorry customized service, and customized service and products for the eco-aware tourists that are in this place. I don't know if you are hearing me. Is everything fine?
Yeah, everything is
Yes, we
fine.
do.
That you
Sorry,
are.
because I just have one screen, so I can't see you. Okay, so basically, with this customer, this tourist profile, we can well, these entities can have enhanced and customized products and services for these eco-aware tourists, which on the other side are interesting for these entities, because they are known as valuable customers for them. And with additional information from Van Campers and Buenavilla, using IoT, both for domoticizing their villas, or censoring their campers, their camper vans. Sorry, they can give additional information to the data space that can be later used in the regional government or the national government to see how sustainable these companies are, etc. No, so more or less, it's what we want to do. We want to promote sustainable tourism, and we think that the best way to do it is to have an interoperable sharing data sharing system for that. Okay, so well, this is a business projection. Obviously, we will use the different methods of payments, both free and premium. Um, but yeah,
Yes, time is up.
sorry. I hope more or less we said what the experiment was about. And if you have any questions, I'll sit down on a seat afterwards. So thank you.
Okay. Thank you, Alex. Okay, time for asking for next speaker. I already put the name of the project in the chat, but next project is sharing sensitive smart building data on MDEX. Can someone from that project raise a hand? Yeah, there he is. Hi. Hi.
Hello. I'm here.
Yes. So the stage is yours, and I will start the timer. Are you ready?
Oh, that's good. How do I share the screen? Here I am.
There is a button near your mic.
Yeah, see. Wait a minute. There we are. Do you see my screen?
Yeah.
Perfect. I won't put it in presentation mode, so I can just select some sheets from the original pitch that we did for this project. As Rajiv said, the project is called Sharing Sensitive Smart Building Data on Amdex. And I will just show you some sheets to show you what we're doing and what Amdex is. Maybe to start with a picture of the flow. The use case is about sharing sensor data that's coming from buildings and public places, mainly in the Amsterdam area, which means the city of Amsterdam and all the communities and municipalities around Amsterdam. And it's about making this sensor data available in a safe way and considering all the privacy and commercially related sensitivity on this data, and making it available, for example, for cleaning companies who want to provide services in the building, or security companies providing services in the building. What you see here is a picture that shows at least the parties involved in sharing this data. Another picture, Amdex, which is actually an initiative which is already 4 years on its way. Amdex is the Amsterdam Data Exchange. It's an ecosystem which should make it easy to share sensitive data. We started in the Amsterdam area, but it's a national initiative in the Netherlands to make data sharing easy. We adopted several standards, and you see that also the Amsterdam Internet Exchange, AMSX, is involved, the University of Amsterdam, the Amsterdam Economic Board, SURF, which is a scientific organization in the Netherlands, and Dexus, which is my company who provides data exchange services. What we're doing, we're building a data space for sharing smart building data. And that's where Amdex comes in, and also where iSHARE and FIWARE will come in. Just to show you who's participating, we have a lot of parties involved, and it's good for you to know that the I4Trust experiment is part of a larger use case we're doing on Amdex. So we're actually doing this smart building use case on Amdex, and I4Trust is an extra project we're doing to involve iSHARE and FIWARE components in this project. What you see here is that we have actually a great division of the Innovation Hub, a project management involved party, which is me as part of Dexus. And we have technical implementation partners on the right here. And we have some data providers, intermediary, and data users here on the left. And we have a lot of parties involved, like municipalities, users, data providers, etc. Actually, the responsible parties sharing data. One of the last pictures, here you see the architecture for Amdex. And what's good to see is that we have a layered approach where you see governance on top, data exchange in the middle, which provide the actual transactional layers for providing data exchange and data markets, etc. And the actual providers and data exchange itself between users on the bottom, where we see that for iSHARE, we're looking at how can we use iSHARE in this Amdex environment on this governance layer, and also providing identity and authority and authentication mechanisms, and how can we make FIWARE enabled services able to connect to this Amdex infrastructure. So this is how we approach it. Also, we have a lot of goals. I won't say them, but the goal is clear. We should make sharing of data more easy, so parties like cleaning companies, security companies, and public service companies can actually use this data. And the last picture, we have a lot of parties involved. These are all the people involved directly from the partners in this project. And that's it, Rajiv. Can I stop sharing?
Yes.
Yeah,
Great.
I can stop sharing
Thanks.
here. There you are.
Yeah, thanks. You finished before time. That's great.
Oh, that's good. Okay.
Thank
Great.
you. I will
You're
now.
welcome.
I will. Yeah. Now I will invite the next speaker on the stage. I already put the next project name in the chat. That is DTAS for Hierro, and I see Angel already on the stage. Hello.
Hello, good morning. Okay, I'm gonna share the screen. Okay, so our project is DTAS.
We don't see your screen.
Can you hear me?
We can hear you, but we don't see your screen. Are you sharing something?
Yeah, in principle. Can't you see it?
No.
No. Let me see, because in principle I was okay. I am okay. Let me see. Okay, now can you see it?
Yeah, it's loading. Yes, now we can see. So we can start.
Okay. Sorry for that. So yes, so our project is about creating a digital twin as a service for aeronautical infrastructure. So basically, our main goal is, so just to give you a bit of context, air navigation service providers is basically the guys that control airplanes, and all the efficiency, safety, and capacity of this system relies on the infrastructure, technical infrastructure that ANSPs have available to control. So it's radars, radios, and so on. So we have a whole community serving this purpose. We have manufacturers, contractual equipment, engineering, installators, consulting, and the navigation service providers and maintenance. So the performance of these equipments will define ultimately the performance of the whole system, the capacity of the whole system. So avoid delays, improve the routes in airspace, and so on and so forth. And we have, of course, we always want to improve the proficiency of a service, but in European Union, we have an implementing rule that imposes an efficiency and performance scheme on the aviation sector, on the air navigation services sector. So we need to improve this efficiency. The problem is that all these actors don't have the right information and the common information on the performance of these systems that will allow to create more value, to improve the technical infrastructure, and to improve the overall system. So what we are proposing is to create a digital twin of radio to start with, and we will be able to create raw data and be able to produce KPIs. So the ANSP and the other actors will know the real performance of the system. In that way, manufacturers can improve the systems, and navigation service providers can improve the overall set of systems to create it optimized, and other consulting engineering and installators can optimize their way of working, ultimately creating better services for the passengers and for the European economy. And this is not just aeronautical system, is a worldwide system with worldwide regulations. So this is something that we would like to extend to the rest of the world, because as you know very well, aviation goes without boundaries through continents and different regions. So the challenge is to increase safety and reduce energy consumption and of the systems, and also more performance means reduced CO2 tons to airspace because of shorter routes and better flight profiles. So the consortium, for the consortium, LISLA is the project management and the ATM expert, so designer of the whole, let's say, business view. We have Faubourg Numérique, which is the DIH based in France. Attica Realities, it's, let's say, it's the technical project management. It's provider, it brings into the digital twin prototype already into the system, and we coordinate the development, backend, algorithms, aggregate data, etc. It's also based in Spain. We have Obisco. Obisco will be the consumer of aggregated data and machine learning estimations and challenge our conclusions. It's a Luxembourg company with over 20 years in the air traffic management system. AWR Technics, it's operation and maintenance. So they will operate the radio and input into the engineering, and they will be provided raw data and aggregated data. They're based in India. We have WAPI, which is also a Spanish company that is providing cloud services and software context and development.
Sorry.
And AMS, which is a system provider. And I wanted to do it short as for the request. So if there is any question, but I think this gives a view on the expected benefits and consortium as requested.
Yeah, thank you, Angel, for the nice presentation. Okay, then I would like to invite the next project on stage. The name I already put in chat, that is scaling up unattended delivery and collection. I thought there was a raised hand. Yeah, hi Annette.
Hi everybody. Wait, I'm trying to share.
Yeah.
Share screen. You see my screen?
No, not yet.
Ah, I know what I did wrong. Sorry.
Mm-hmm.
It's loading. I'm sorry. You see it now? I see it as being shared.
Yes.
Correct?
Yes. Yeah. It will start.
Thank you. So yeah, hello everybody. Thank you for sharing all your experiences and projects, and I shall briefly share ours. We are a consortium involved in scaling up unattended delivery and collection. That's in the last mile, so that's in e-commerce and delivering to receivers and collecting returns in a sustainable manner. We already did a proof of value for that, and I would like to share that with you because that's the easiest way, I think, to share what we did. It's only 1 minute. Oh, wait, I hope this. Yeah.
We cannot listen the audio of the video, so perhaps if you want to explain the video while it's being reproduced.
Yeah. So it's being delivered. Yeah, I'm sorry. There's an audio with the video. I don't know why it didn't work, but I'm sorry. What we showed is like unattended delivery integrated in the supply chain of the retailer. In this case, it is a food retailer. It's a local supermarket here in the Netherlands where we did a proof of value with for 4 months. And it's completely automated in the sense also like it's set the temperature in the climatized boxes at the right temperature. For fresh produce, you can also have a non-climatized box for groceries, but also for parcels. And the lessons we learned there was that on the business model, that was of course very important, whether a transaction fee business model would work in this market. It seemed also from the other research we did that we could include the direct to consumer channel, and that what would add value is what our company was already working on for a long time, the valorization of the digital component. So in scaling up this from this proof of value, we are very happy to be part of I for Trust. And because we think in the infrastructure help and data sharing and secure data access, identity provider, etc., that will very much help. Our consortium is comprised of the Digital Innovation Hub, Technologies Added, who are also helping with smart manufacturing of the hardware. Port Art, that is involved in a third-party authorization register. Then, of course, we have FIWARE and iSHARE in this. We also would like to pay really attention to conveying the message to a larger public. So we have the News Voice Network also in our consortium because they're very good in communication of complex messages. Then what we're very happy with that in the direct to consumer, we work together with a primary producer who has a very really artisanal way of producing goat cheese from her own goats on a farm. and she sells directly to the consumer and on local networks and on quite high-end restaurants because it's really a very good product. And at the other end, we have a food retailer, large food retailer of the Netherlands participating. And for us, that's very important that we can also do the data sharing and data access with large systems.
Time is up.
Okay. This will be then the result. Sorry.
Yeah, no worries. Sorry, more to time box it. Thank you, Annette. Thank you for the presentation. Of course, I will see you in the mentoring program, and people can connect to you as well. Okay, I will now want to invite the next speaker for the next project, that is Smart EDI port. Is anyone from that project? Okay, I think there is no one. So let's move on to the next one. But if someone from Smart EDI port joins, please, or can see the message, please raise the hand later on or reach to us via chat. So next project is Trust Your Data Center Data 2. Hi, Larry.
Hi, everybody. Mhm. Just a moment. All right, can you see the screen?
Yes, we can see the screen, and the stage is yours. Thank you.
Thank you very much. Let's go then. So basically, our project name is Trust Your Data Center Data 2. Idea is that we create trust between data centers' metadata. So we decided to divide the challenge into two. Pretty much, the first challenge is that we share the data trustfully between two data centers, so we can experiment with two data centers. The key problem here is that a lot of that data is confidential in nature, so you cannot share it freely. And currently, there doesn't seem to be any unified way to broker data between data center services. So that's something that we want to solve. And the idea is that in the end, we envision that you go to the marketplace, you buy tokens, and then you access server capacity. It's as easy as that. Currently, if you operate with the big hyperscalers, they have a good monetization strategy. But this is more aimed towards the smaller data center operators that don't have that capacity and don't have that capability. Business projections for this, they are kind of high. And the data center business is not going to go down. It just depends that who are the players in the data center. We think that this will grow, and there is some possibilities here, definitely. There are some existing solutions with AWS, for example, but we think that this proposal would be really good for the small and medium-sized businesses. Shortly about the team. The team is, we have a DIH from Savonia. So they are doing the technical mentoring and helping us with the technology. Then Profirator is the company where I'm from. And we are more like the technology experts on this. So we provide the tech and help then the other stakeholders to execute their job. And the other two stakeholders, most importantly, are Luola and Controsec, which are actually data centers. So the idea is that we install the technical enablers into the data center and experiment first with the two data centers, so Luola and Controsec. We exchange the operational data between the two data centers. And once we are sure that everything works with these two, then we will expand this. So one of the ideas is that we generate data models that can then describe the data center capacity offering. So the idea really is that once the data center has this technology, they want to join our data space, we introduce them into this, help them with the technology, and then they can use the standard data models to describe their business offering. And the idea is that the end customer then can go to the marketplace, for example, look for the best data center in the marketplace that suits their needs exactly, and ideally do a one-click purchase. All the other problems like contracting and stuff like that is handled by the IFA technology. So, and that's about it. I'm not gonna take any more of your time. If you have any questions about that, my name is Ilari Mikkonen. Reach out to me. Let's talk. Thank you.
Thanks, Hillary. That was great. Before time. Yeah. Okay. Thank you. Then I will invite the next speaker, and that is from the project menu space. Somebody from menu space? Nicholas? Oh, okay. Shall we move to the next project then?
Sorry, can you hear me? No, I was saying that John should be ready, John Ward, to present this project. But
okay, it seems he's having some technical issue. So okay, let's call him later. Let's move to the next project then. It's Tidy City.
yeah, Nuno is ready, Charlotte, I think. Okay.
Hi, Nuno.
Hi, how are you? Can you hear me?
Yeah, I'm good, thank you. We can hear you well.
Great, so let me check to share. How do I share my screen?
There's a button at the bottom near your microphone.
Oh, okay.
Hi guys, can you hear me? Apologies, I got kicked out there for a second.
I think you are from Manuspace, John.
I am indeed, yeah. Oh,
yeah. Because I invited the next project already, so I'll invite you back on the stage after this is done. If
perfect.
That's okay.
Thanks, guys.
Yeah.
All right. May I proceed?
Yeah, no, you can.
Can you see my screen?
Yes, we can see your screen. Thanks.
Okay, thank you. So good morning and thank you for having us. So my name is Nuno Rodrigues. I'm from Logimate, and our proposal experiment is a smart data solution to monitor city infrastructures, and we will try to do it using cameras in vehicles from the street level. Okay. So the challenge we propose. Oh, sorry, I didn't pass here. Just 1 second. All right. So the challenge we propose to solve is the creation of a data ecosystem for the smart monitoring of the rapidly increasing number of city infrastructures. Now, why do we need such an ecosystem? Well, basically because to be attractive, cities have invested more and more in infrastructures to increase the quality of life of citizens and visitors, tourists, for example, especially in Funchal, where we are based. Now, I can give you two examples from the city of Funchal, clearly illustrating this. So the city, like other cities, but Funchal has more than 5,000 waste recycling containers that are spread all over the city. And this is a source of dozens, if not hundreds, of waste-related complaints every day. Also, and during the approaching season of Christmas, we install 1.2 million decorative lights that have to be monitored and attended to 24/7. Now, these are just two examples among many other infrastructures that the city needs to provide high-quality services in education, mobility, security, welfare, and much more. The problem that cities are facing with these infrastructures is that they have to monitor all these increasing number of infrastructures 24 hours a day, 7 days a week, 360 days a year, which is a staggering amount of equipment, and it demands resources which are beyond their capacity. Now, the approach we take with our project is based on the belief that we can only keep this situation under control through an active collaboration network between public and private entities, aided by technological solutions like the ones we propose here that combines data sharing, intelligent analysis, and process automation to facilitate the monitoring and the operations to keep all these infrastructures up and running. So Tidy City proposes a step forward in this in a strategy to monitor these infrastructures by equipping vehicles with mobile devices that capture street images, like the ones you are seeing on the upper left corner, and they automatically detect and classify problems in public visible infrastructures. Okay, these images are collected by cars, and they are sent to a server, which, based on AI models, classify and deliver the data and share the data with the stakeholders interested in doing so. Within the scope of this system, of this experiment, the system will be able to detect and record the GPS location of occurrences related to outdoor advertising, energy grids, and waste disposals. That's our target for the experiment. The detected occurrences will be shared with each corresponding partner, and they will integrate the information to optimize their operations. However, there's a great challenge for the realization of these ecosystems, and which is to have a secure and trusted data sharing digital infrastructure. And that is exactly what we propose to solve using i4Trust components. So here we need high quality and high frequency street level data. This is a very important source of data and a very powerful one, but it's also a very sensible one. So we need to tackle two main factors to implement our experiment: access control and availability. Now, access control is vital to guarantee compliance with European Union regulations and national regulations, and in particular to assure that only authorized entities with the justification to monitor certain type of occurrences can access the corresponding data. Data availability is assured by the distributed nature of the solution, where critical data is not dependent on a single point of failure and is always available for every operator to carry their activities independently. Now, besides guaranteeing trust and access between partners, our solution also guarantees that all data consumers get accurate and up-to-date information regarding occurrences. At least that's the objective that we have with our experiment. Now, we rely on i4Trust framework to successfully implement such an ecosystem of data sharing. Now, our consortium is composed of 6 SMEs and a digital innovation hub. Logimade and Transbag are logistics companies, and they will have the role of data collectors. They will use their vehicle fleet and couriers to collect images from the city of Funchal and implement privacy by design processes at the collection point. Okay, Logimade will also integrate waste occurrences data into the waste management system of the city of Funchal that the company runs. Invisible Lab is a software company with AI expertise, and they will be an intermediate data applying their expertise. Sika Prep and Energy is an energy infrastructure company, Promerge, an advertising company, and Madeira Waste Recycling, which is a waste recycling company, will be data consumers to consume all this data being produced. And then we have the Smart Islands Hub, which is a FIWARE hub. And we also have, though not formally involved, the City of Funchal, Santa Cruz, and IREM interested in monitoring and observing data as well.
Time
So,
up.
sorry for taking a bit longer than the 5 minutes.
Yes, no worries. Thank you, Nuno. Okay. Yeah, John is already with us, so it's from Manuspace. So yeah, John, when you share your screen, you can start already.
Sounds good, guys. Hopefully you can see my screen, and apologies for the little mishap earlier.
Yeah, we can see your screen. You're good to go. Thanks.
Perfect. So I am John Ward from the ManuSpace Consortium. Our challenge is related to pharmaceutical and manufacturing. As more and more pharmaceutical and biotech companies choose to outsource their manufacturing projects, companies need to evaluate the performance of the contract manufacturing organizations who they outsource to. Now, this outsourcing leads to all sorts of increased risk of non-compliance to procedures. Data integrity is essential in the pharma industry to make sure that end products meet all the required standards. And this is for good reason. Any misstep in this myriad of complex supply chains can have life-changing consequences. Enabling digitization and automation of cross-organizational business processes integral to pharmaceutical manufacturing will help improve supply chain security. But more importantly, it'll really help the time it takes to get these medicines, life-saving medicines in many cases, into the hands of the patient. So reducing that time to the patient, which is a critical factor for the industry. If we think about if we look at the pharmaceutical industry and we think that these guys have just saved us from COVID and they're saving the world, we have many advances in the industry. That means it's cheaper and easier to ever manufacture and distribute drugs with significant benefits. But if we just peel away at the layers of this, we see a system that's built on, I guess, older foundations. We have legacy data systems that don't communicate with each other. You have manual data extraction, which can be time consuming, the filing of data, the checking the validity of the data. There's distrust with third-party vendors. There's cumbersome compliance and regulations. And all of this results in lost time and lost money. Our consortium has a very long track record within the pharmaceutical industry. I'm John Ward from Cerblock, and we're a software company that helps companies gain complete supply chain compliance through actionable insights and data-driven collaboration. Nexa Enterprise Asset Management is a pharmaceutical manufacturing company that delivers project engineering expertise solutions to the life science industry. Hierro, also a pharmaceutical manufacturing company providing technical consulting and staffing services for the leading global biopharmaceutical companies. Unison Process Solutions is an industrial machinery manufacturing company with leading suppliers and producers and servicing partners of process equipment. Our DIH is Irish Manufacturing Research, which is a digital innovation hub based here in Ireland. IMR's goal is to demystify, de-risk, and deliver emerging technologies and new knowledge to enable industries to succeed at the cutting edge of advanced manufacturing. Our consortium have just gone through the roles. We have two challenges within our data space experiment for iForTrust. This is sharing process control data between manufacturing companies and sponsor pharmaceutical companies, and then the sharing of maintenance data and management data, so equipment status data between whether it's a contract manufacturer, it's a third-party vendor, it's a pharmaceutical company looking to get insights into the status of equipment. Quickly go through that. So again, we're doing all this through solving through iForTrust enablers. We have our Trust Authority, which is iSHARE Satellite, and our data providers and data space administrators. There are currently 14,000 permits issued by the European Medicines Agency for pharmaceutical manufacturing in the EU, and 60% of all pharmaceutical manufacturing is outsourced. So you can imagine that's quite a big challenge to be solved. Our customer segmentation comes down to pharmaceutical sponsor companies, contract manufacturing companies, service providers, and consultancy companies. Our team, we have quite a long track record within the industry. I myself have 10 years working within biotech, and most recently as Pfizer's Global Smart Factory team. Dan is a veteran of the industry, included working at a lot of the top pharma companies. And then we have Mick, Michaela, and Dermot who fill out the consortium. Sorry, this is an old presentation. You can see everyone has been copied across there. Thank you. That is the ManuSpace experiment, and we're currently, we're trying to unlock the value of contract manufacturing data by sharing it between consortium partners.
Great. That's before time, and thank you for a very nice presentation. Indeed, very interesting. Thank you, John. Then I would like to invite the next project speaker on the stage. That is from CAST. Can someone from CAST join the stage? Hi, Marcel.
Hi, Rajiv. Good. Let me show my screen, if that works. Unfortunately, it doesn't. Give me a second.
Yeah, sure.
Does that work? Do you see?
Yeah, we see your screen and we can hear you well. So stages.
Thank you. I will leave it in small mode. This is the only thing that's working right now. So hello, everybody. We are from Carbon Capture Shared Auto Trails, or short CAST. And the process that we are looking into in our I4Trust project is carbon capture, and specifically carbon capture with pyrolysis. So how carbon capture works in our process basically is we are taking some sort of biomass that is currently having some carbon inside. So flowers are doing photosynthesis. They take the CO2 out of the air. They store it as long as they are alive. And usually, when they would die, they would dissipate the CO2 back into the earth again. And what we have is a process where we are preventing this biomass from dissipating CO2 back into the earth again, and keeping and transferring it in a solid product called a biochar, so that you can put in a confinement facility. And our process basically has a lot of different organizations. For example, a farmer who's collecting biomass and who is creating data for his biomass. So I have here 2 tons of wood chips. The biomass is being transported to some biochar plant that transforms that biomass into biochar. This is a chemical process where you have many different parameters, and where also the end product can have different purity grades. For example, it can have 80 or 90% of biochar of carbon inside this biochar. Then this product is being transported to a confinement location where it's supposed to be stored the next 20, 50, 100 years to keep carbon under the ground and not fire it back up again. And the problem in this process is that all parties in this process can arbitrarily forge and corrupt the data. So that might have a pretty big impact if, for example, the biochar plant is saying, okay, this biochar, this half a ton of biochar that I produced has an 80% purity grade of carbon inside, but in fact it only has 60%. This is a big problem, a monetary problem, and of course also an environment problem. And it cascades down the whole chain. So if there's one a kink in this chain, everything else that comes afterward is a problem. And what we are doing in our process, in our CAST project, is we are using iSHARE and FIWARE to give a context broker and iSHARE accounts to each of these parties in the consortium or in this chain. That each of these parties can put the data in there, and that other parties can certify if the data that someone put in there was correct. That might be an independent lab analyzing the biochar, saying, okay, it has indeed 80%. It might be someone later looking that the biochar is still in its confinement location and has not been dug up again. And this is what we're doing in our project. Building such a system that puts attestations and the roots in form of a hash on a blockchain to preserve integrity and to create a real end-to-end shared audit trail that we can use and hopefully make the whole system better. Our consortium consists of technology providers, my company JadenX, iExec, a French blockchain company. We have 2 domain experts who are experts in that chemistry and carbon capture research for 4C GEM and lab automation networks. We have in our project 4 different data providers that we are basically these organizations that we have in our consortium will simulate, that we have the one end-to-end process, end-to-end for the experiment. And then we have two parties, WB Node and Act for Carbon EV, so a non-profit organization that is going to disseminate and communicate our work. We are supported by the Digital Innovation Hub from Vorburg Numeric and Quantum. And yeah, 5 minutes, that's it. If you have any questions, feel free to shoot.
Great presentation. Thank you, Marcel. Okay, also on time. Yeah. And next, then I would like to invite the next project speaker on the stage. That is from DARE, Data Spaces for Smart Energy. Hi, Nikos.
Hello. Can you hear me?
Yeah, we can hear you.
Okay. Let me share my screen.
Yes.
Can you see my slides?
No. It seemed you shared something and then it went off. Maybe you have to do it again.
Let me share my entire screen then.
Yes, we can see your screen. Yeah.
Okay, so
It is yours. Thank you.
Hello from me. So the goal of our project is to improve the energy efficiency of commercial and residential buildings by leveraging data produced by smart devices located inside these buildings. And in order to highlight the expected outcome of this impact, let's see two users, John and Anna. John is using a traditional energy management system where Anna is used the energy management system enhanced by our technology. So both these users fall asleep without adjusting their thermostat. John will just simply consume unnecessary energy and probably will have an uncomfortable sleep. But their enhanced energy management system of Anna will realize that Anna has fallen asleep, maybe using some data from her smartwatch, and it knows that usually when Anna falls asleep, she adjusts the thermostat, so it will react accordingly. Another problem is that John and Anna may have an issue with the gas boiler. John will just receive an increased bill, and then he will realize that something may go wrong. But Anna's energy management system will detect that her gas boiler is consuming more energy than required, and it will react by notifying the gas boiler management service. So our approach is to use data generated by IoT devices located inside smart buildings. Firstly, we are going to use historical data to train artificial intelligence models. We are going to create two AI models, one for detecting anomalies and another for providing energy efficiencies tips. And then we're going to use real-time data in order to take decisions based on what's happening inside the smart buildings. Our starting point will be a data sharing architecture that we have already developed. In that architecture, we are using this gateway called Web of Things, which is a W3C standard, which is nice, but it does not support, it does not have great support for API, and it cannot be used in real deployments. In their project, we are going to leverage FIWARE technologies and in order to have improved API support and greater TRL. In our existing architecture, access control is implemented using verified credentials, and access control decisions are made using access control lists, which again, this is good enough for small use cases, but when it comes to large scale deployments, this does not scale very well. For these reasons, we are going to explore iSHARE technologies in order to get improved identity management, as well as support for finer grained policies that will be suitable for our experiment. And we are going to use the same client applications, which is nice, since we're going to demonstrate interoperability among existing deployments. So the role of the data provider will be held by two SMEs of the consortium, Plegma and Domex, which are two companies active in the smart energy domain in Greece. The trust provider will be held by Exceed, which is a spin-off of the Athens University of Economics and Business, active in the area of self-sovereign identity technologies. And when it comes to data consumer, one of our partners, Streamall, will develop the two AI models, and the fault detection AI model will be used by Gas Options, which is a large gas installation service in Greece, and the energy efficiency Tips AI model will be used by Hthon, which is also a very large-scale building management company in Greece. Our team also includes the Digital Innovation Hub of the National Technical University of Athens. We are a big consortium, but we have already worked in the past together, so there is a good chemistry among us, and we are really looking forward to implementing this project. So, thank you.
Thank you. Great. Just on time. Because thanks for the nice presentation. Okay, then I would like to invite the next project speaker on the stage, and that is Solar Charge API. Okay, hi, Christos.
Hello, can you hear me? Great. Okay. I'm Christos representing Solar Charge API, and I will share my screen very quickly.
Yes, please.
Okay. Now you're seeing my screen?
Yeah, we can see your screen. So stage is yours.
Perfect. So on our side, we are in a consortium focusing on the combination of solar energy and e-mobility. The consortium consists of Grid One, a company focusing on smart meter data in Croatia, Innovation Center Nikola Tesla. It's part of the University of Zagreb, and it's our DIH for this project. And then in Greece, we have Ilios Res, that is a solar energy operations and management company that will be providing data. EV Loader, which is the company I work for, that is a company that is managing charging stations and developing software solutions for smart charging. Agrivolt, which is a CPO, a charge point operator active in Greece, and EV Motion, that is a CPO active in Cyprus. And the challenge we will try to solve is to achieve that interoperability among different verticals of the clean energy and e-mobility space. And the end goal here is to provide guidance to drivers for the specific intervals they can charge their vehicle with surplus renewable energy. So in days with high solar irradiance or high wind capacity, to be able to inform drivers that this is a correct time to charge your vehicle, and also your cost will probably be lower. And so far, in Greece and in Cyprus, no such initiatives have taken place because there is a complete lack of information exchange between the different stakeholders. So the e-mobility stakeholders have no clear visibility on what is happening on in renewable and generation assets and the grid in 1 hour's time. So what we will be doing for this project is to enable both the solar producers and the different EV charging stakeholders to share information through the context broker tool. And of course, they will be authenticated using iSHARE and FIWARE KEYROC authorization processes. And the end goal of all this is based on this information exchange. The 3 companies that are participating in the consortium that are related to EV charging, so EV Loader, Acrovolt, and the EV Motion Cyprus, to be able to inform the drivers for the correct times to charge their vehicles. And also another objective is to differentiate this between the correct time to charge your vehicle if you're using a rooftop solar-mounted solar panel, or if you're just trying to optimize based on the conditions of the broader grid. Yes, so this is, I also leave my contact details here for everyone that wants to shoot any questions to us. And of course, if there are other synergies with other projects in terms of e-mobility, data sharing, I would also be interested to discuss with you.
Okay, great. Thanks, Christos, for a very nice presentation and before time. Okay, then I would like to invite on the stage the next experiment, and that is CATS, Carbon Agri Data Space. It's Dimitrios, if I spell that correctly. We can't hear you. No, not yet.
Not yet. Can you hear me now?
Yeah, we can hear you now, but it's a bit
Nice.
sounding like you're a bit far away.
Sorry. There's something with my headphones, I think. Okay,
Okay.
I'll try to share.
Yeah.
I hope that you can see my share.
Yes, we can see your screen. So
Okay, thank you very much. So this is about the CADS project. What is the ambition and the overall concept beneath the CADS project? So it is proven that agriculture is one of the sectors that emits the most greenhouse gases, but there are also many opportunities to reduce these emissions. From our perspective, to reduce carbon emissions and increase carbon storage, farmers need to have knowledge and incentives. To go from data to knowledge is something difficult. So the state of the art as it is now, it says that IoT devices, farming management systems, etc., produce data, which data are very useful, but they are not transferred as a knowledge, useful knowledge to the farmer or to the overall value chain. So the first thing is to take this data, the heterogeneous data produced by this system, and produce knowledge by this, especially focusing on carbon emissions and carbon footprint. And in addition, there is not an easy way and a trusted way to leverage sustainable practices into income. So we have the opportunity to generate proofs of impact for sustainable practices for zero carbon production in the food supply chain, but yet we cannot leverage these proofs into markets. So we need to share data and generate these proofs and push these proofs to the market. From our point of view, we have to produce a trusted data sharing infrastructure which produces knowledge and gives incentives and support the key players in this supply chain to produce the proof of concept and monetize this proof of concept. So this solution, from our perspective, is including a creation of a data space that facilitates multiple users to share data in a homogeneous way. We have chosen a data sharing architecture that will reduce organizational and technical costs, but also ensure coherence and the notion of trust. So in this technological infrastructure, we will have blockchain and distributed ledger technologies to enhance traceability and to enhance the trust for the key players that will provide data and use the data so as to produce this proof of concept. The infrastructure is designed to be interoperable with other data sharing intermediaries, and the overall ambition is to leverage the existing data from farmers, open data, and data that is being produced by farming management systems in a verifiable and transparent carbon footprinting proof of concept, and then to support this procedure to go to the market. In this way, we hope that we will create impact in a fair and transparent way. You can see the project in the overall architecture of the project. We have the data providers. The project is key players that are participating in the project comes from Italy, France, Spain, Ukraine, and Greece. So we have the data providers, which are producers that are using farming management systems, IoT devices, and they have their own custom applications to produce data. We will build an infrastructure that in a decentralized way, data sharing will be enabled. And in the meantime, a heterogeneous data will be transferred and transformed to a way that a carbon model, estimation model, can use this data so as to produce proof of concept for the overall production. So at the end, the farmer, the producer, the key entities will have services that can use their own data so as to produce the carbon estimation based on a model. This model will be is a scientifically proved model that is already been used in several situations and case studies, and will be also be applied to this project. If we can look at the architecture a bit deeper, we can see that the data providers we will have the ability to use the data sharing intermediary of the I4 Trust, which will be optimized for the CATS project. And this way, the intermediary will be able to take the data, collect the data, transform them, and feed the model for carbon estimation, for carbon emission estimation. And throughout the model, this model will actually feed the mobile applications, services, web services that will be used by the key entities and the key target users of the project. So at the end, the service for the end user will be an estimation facility, a trusted estimation facility, with which the entity will be able to estimate the carbon emissions and prove that it follows all the necessary guidelines and tools that minimize these emissions.
Yeah.
So at the end, we will create a verifiable, yes,
The time is
carbon
up.
footprint. Yes, thank you very much.
Yeah,
thank you very much.
Okay, thank you. Sorry.
Thank you very much. Thank you.
Yeah. Okay. Then I would like to invite the next experiment on the stage. Data space for multimodal passenger mobility. Start.
Hello. Can you guys hear me?
Yeah, we can hear you.
That's good. Let me see if I can find the share screen button. That should be this one.
Yes.
Is this visible?
Yeah, we can see your screen.
Very good. I just stepped in yesterday. The lead in this consortium is Ferdinand Burgersdijk. He's currently in the Thalys, so I'm speaking on his behalf. We've been working for a longer period already on a multimodal traveling solution. So consumers can travel through different countries by different traveling means. So this is a blockchain-based solution. It's basically an open playing field, if you will, where anybody involved in facilitating the consumer's travel itinerary can participate, and that would mean there are several roles you go through when you travel, or like the parties that provide the services. There's a physical service provider, which, for instance, can be a company providing train rides or even up to rental scooters. There's a digital service provider that, for instance, can facilitate the ticketing. And there's, of course, the consumer. And there's also like data access by the authorities where it comes to legislation and stuff. So the route you basically, or a consumer goes through, is planning a trip, then actually booking a trip, then there's the validation, and there's justification of payment. And those 4 steps are set up in such a way that it doesn't matter whether you choose a scooter or a train, for instance, and everything is handled accordingly. Transactions are stored in a blockchain, and the current previous solution we already had, which evolved over time with talking with bigger identity providers and public transport companies. That we have collaboration ongoing with iSHARE already. So all the involved parties are authorized and controlled. And so is the exchange of information within that field, and everybody participating. So the physical and digital service providers, consumers, and authorities are all identified and are either legal or natural person, or legal entities or natural persons. So yeah, I think that's it in a nutshell. If we go one step deeper, it's going to be a lot of details. But this is like in a nutshell a solution with secure data sharing based, providing a solution for international travel. I'm currently focused on the European continent. So that would be about it. I think I'm done. Okay. Way under 5 minutes.
Yeah, great. Thanks, Gerard. Thanks for the nice presentation. You're getting a lot of applause. Nice. Okay, then I would like to invite on the stage the next project, that's blockchain for ESG. Hi, Roman.
Hello. Do you hear me?
Yeah, I can hear you.
Okay, hello everyone. Now I share my screen. And do you see my presentation?
Not yet. Yeah, now we can see it. Thank you.
Okay, great. Okay, my name is Ron Kravchenko. I'm CEO of FIWARE Solutions, and today I'm present our experiment, blockchain for ESG. So our main domain where we will build experiments is domain of ESG or climate-related risk management. So our vision to provide ESG data broker to make possible to automate the process of ESG or climate-related risk management and assess the impact of climate on financial results and business assets from one side, and assess the impact of business to environmental pillar, and share this data with financial institution, first of all, with investment company who seek to invest in sustainable companies. So we're focusing on solving the problem of ESG data management in food industry and provide solution to make possible and improve ESG data availability, integrity, and reliability. Automate the process of ESG risk management for industrial companies across value chain. And finally, to improve food safety and sustainability. By ESG data, first of all, we consider the environmental pillar, and this data includes ESG sustainability strategy of company, data about carbon emissions and footprint under 3 scopes, the data regarding energy and electricity management and efficiency, water and consumption, and finally, climate-related risk and opportunities. So our idea to build a green finance broker that can convert ESG data and assets from industrial enterprises into new sustainable value. And from another side, we can share this data to financial institution to assess sustainability and climate-related risk across investment portfolio. And as a result, we aim to improve capital allocation taken into consideration climate-related risks of such industrial enterprises. In our case, in case of our experiment, it's about the industrial enterprises in food industry. Our experiment based on adoption of TCFD recommendations and frameworks, these international standards, how we can assess and manage climate-related risks and disclose information about this process. And we use blockchain from Hyperledger Fabric to verify the life cycle of ESG data and climate-related risk management for food industry. And for this experiment, we provide some part of our technology from Electroda product, and during experiment, we will build application ESG Electroda. This application, blockchain-based self-verified ESG data broker, based on using FIWARE components and iSHARE components. We in our consortium participates 2 companies from Ukraine and 3 companies from Spain, and we facilitated by IoT Digital Innovation Hub from Spain. And this the system architecture of our experiment, in which involved data and service providers and data consumers. Some of data consumers we emulate, such as financial institution, because due the conditions of IFA trust, we can't involve the real entities in this experiment. And our idea to build end-to-end ESG data broker to automate and make possible data, ESG data gathering, data processing, and sharing data by disclosing in form of sustainability report and with verification on blockchain. And our next step will share the results of IFA Trust experiment in the next of our project under Horizon Europe Grand Call. This also project related to trust to food industry. And the second, we aim to scale. We'll aim to scale our solution in transportation sector. Yeah, FIWARE technology also in Singapore region. So thank you for your time.
Thank you, Roman. Thank you for a great presentation. And with that, I would like to invite the next project on the stage, and that is from Ideas. That is integrated engineering data sharing.
Okay, so this is Ideas, Integrated Engineer Data Sharing. I'm Michela Petruccio, and I'm presenting this project from the FIWARE Digital Innovation Hub. And this project is aimed at promoting a sustainable and efficient and sustainability and efficiency in the construction sector, in the smart construction sector. The challenge of this project is, first of all, the optimization of processes in the construction sector, both in terms of time, so reduction of time needed to complete the technical operations and resources, and also in terms of waste, so reduction of waste in terms of, as I said before, time, materials, optimize the use of resources and budget. As we know that 70% of the project sectors are out of times and out of deadlines and budgets. So what is the solution that we want to achieve through data sharing? We like to use, well, we want to use data in order to take this data and collect the data obtained through the use of IoT sensors inside and outside the buildings, in order to create a digital twin. The data generated by the single construction site, in order also to monitor CO2 levels in environments, will be collected on a dashboard, and a digital twin will be created in order to simulate a construction site and monitor all the operations and achieves the best possible models in terms of efficiency and sustainability. The consortium is made up of 6 smart construction companies. The lead applicant is Energico, a company operating in the smart building and construction sectors in 7 years, and which will be the data provider. And then we will have 5 more building construction and smart building companies who will be the data users, and there will be also the digital innovation hub who will act as the intermediary. This is the model that we will use, that we foreseen in order to develop this project. The 2 service providers will be able to share data in an trusted space. So construction companies will access trusted space, and they will represent data providers and in the environmental health monitor provided by the monitoring companies. And so through the use of iSHARE technology, it will be possible to provide instruction about the condition, and as I told you before, foreseeing the most efficient possible model in order to ensure sustainability of operations and efficiency in the smart building and construction sector. Here we have a building projection. Sorry, a business projection. So there will be a software which will be offered, and the user will decide to if the user will decide to share data, they will gain credits. This is projection in terms of monetary. Terms of yes, monetize the model. So the project staff will be made up of IoT engineer, data analyst, and yes, this is this is the consortium. And yes, I've been running out of time, but I hope I've been clear enough.
Yes.
That's all.
Thank you, Michaela.
Thank you to you for the opportunity. There are millions of images of of me and you here. I will stop presenting. Thank you to everybody.
Yeah, thank you for a nice presentation. Okay. Then moving on to the next project, GlobeShare. Anyone from that project? No. Then the next project, SecuShare. I think SecuShare is not able to join due to some emergency, right? Okay. And let me try again for Smart EDI port. If anyone has joined or is now available from Smart EDI port. Seems like we don't have people from this project, potentially due to some technical challenges. Okay, so then I think we are done. Is there anyone from any experiment which I have not invited on stage? Then please raise your hand or put your name in chat. Okay. I don't think that we missed anyone. Okay. So then I think we are still on time. So as per yeah. So now we will go for a break and until 12:30, and from 12:30 we will have this plenary session continued. But there we will explain to you how the mentoring program is going to be organized, and explain to you a bit about the individual mentoring plan and other areas around mentoring program. So please make sure that you join that, because next is an important session for you to understand how the whole mentoring program works, and that is the journey that we will go through together in the 9 months. So we can go for a break until 12:30, and then we reconvene again. And I hope that answers your question, Hayo. Yeah. Okay. So yeah, thank you everyone for great pitches. And yeah, enjoy your break, and we'll see each other at 12:30.